So this is from page 275, number 29. And it says, trucks A, B, and C working together can move a load of sand in T hours. Okay, I'm going to read the whole thing. When working alone, it takes truck A 1 extra hour to move the sand, B 6 extra hours, and C T extra hours. Find T. Okay, so let's break this down first. It says trucks A, B, and C working together can move sand in T hours. So what I'm going to do is just write that down first in math speak, right? First off, I'm going to go ahead and say, well, that's convenient that they're named A, B, and C. So I'm going to say, let A equal the number of hours for truck A to do the job. Okay, and then I'm going to say, and this is to do the job alone, right? If A is going to do the job by himself, it's the number of hours that A takes to do that job. And then B is the number of hours for B to do the job alone. And then C will be the number of hours for C to do the job alone. Following so far?
Yes.
Okay. Then I'm also going to say, why don't we let T, I mean, it even said, we don't have to write this down, but I'm going to do it anyway. T is, it tells us the number of hours for all of them to do it. So the number of hours to do the job all together. Okay. So using just these, let's come up with an equation. And so what would that be? This is pretty much what you've been doing this whole section.
A plus B plus C equals T? No. Or no, 1 over A plus 1 over B plus 1 over C equals.
Exactly. There you go. There you go. 1 over A plus 1 over B plus 1 over C equals 1 over T. That's exactly what we're doing, right? This is the only real difference between this and the other questions in this section is that now there's 3 things. I think there might have been 1 or 2 that did have 3 things, but this is the idea, right? It takes truck A hours to do something, and it takes truck B hours to do it. C, it takes C hours to do. So then when you do this type of deal, right, then we get we're basically adding rates, right? 1 job in A hours plus 1 job in B hours plus 1 job in C hours is 1 job in T hours, and T is the thing we're looking for. Okay. Well, right now we have an equation involving 4 variables, and we are just trying to solve for 1, right? So it's like, okay, now let's see if we can make this equation that we have a bit more simple. And what I would like, I mean, this is kind of what's going on in the back of my head this whole time, is it tells me to find T, right? Like this is the thing we're looking for. So this guy isn't going to change. I want this to look like this. I have a T right there. It's just now what I'm hoping I could do is rewrite each one of these in terms of the variable that I'm trying to solve for. In other words, if I could get this to be some expression just with T, and this to only have T in it, and same thing here, well, then I'll have an equation with just 1 variable, and I could tell that it's going to look like the types of equations we've been dealing with in this chapter. And so I'll know how to solve it and get T by itself. So that's what we're hoping for. So it tells us that when working alone, it takes truck A 1 extra hour to move the sand. 1 extra hour from what?
T.
From T. Exactly. And so if A is working alone, right? This is what I've now let this be. I've said that A is that number of hours. So what is that? What is one more hour than that total out, than that?
T
How would I
plus
write
one.
it? T plus 1. That's exactly what it is. This is hard for me too, because like it doesn't, you know, it's kind of like, wait, when working alone, it takes one extra hour. One extra hour from what?
Yeah.
Well, the only time that they've given you is this right here. So they must be referring to one more hour, then it would take all of them to do it. So that's the only thing I could conclude here, is that that's what they're talking about. So if that's the case, then B must equal what? If it says that it takes B 6 extra hours, so then B is what?
T plus 6.
T plus 6. Okay, T plus 6. And then it says
Sorry, I had to
truck C T extra hours. So what would I write?
Sorry. It 2T?
2T. There was T plus T. And when I was doing this one the other day, I said, well, it takes T extra hours. So that's T. And, you know, I had just done this. I was like, well, plus 1 plus 6 hours, T plus T hours. But then I'm not going to write it like that. I'm going to do 12. That's 2T. That's the same thing as 2T. So that's what I'm going to do. So now I'm just going to take each one of these and plug them in for my original. So instead of 1 over A, I have 1 over T plus 1 plus. Instead of B, I got 1 over T plus 6. Instead of C, I got 1 over 2T equals 1 over T. And now I am in the situation that, well, is what this whole chapter has been about. And I could just look at this and see like, yep, I have one variable, one equation. I should be able to do some stuff to this to get T by itself, or maybe get it into some kind of quadratic that I factor or whatever. So what do we need to do?
Right.
Yeah, you're kind of cutting out there, but I heard multiply and I heard denominators. And
I did not say multiply, I said kill.
oh, you did. Awesome. Good. Yeah, we are
To
going
clarify.
to kill the denominators. So I'm running out of space on that side. But I am going to think about it like this. So I'm not going to write the thing out here, but you have to imagine that I have. But I'm going to do it on this side. What do I need to multiply this guy in order to kill every denominator?
T plus 1.
Okay, that's one of them.
T plus 6.
About T plus 6, yep.
2T. And T.
No,
just 2T. You don't need T.
2T. And you know, and when I do this, that's exactly what goes through my brain. I just start without thinking about it. I'm like, well, I need to kill that guy, so I got to write this. I need to kill that guy, I got to write this. I need to kill that guy, I got to write this. I need to kill that guy. Whoa, wait, hold up. That will already take care of that one, so I don't need that extra bit. Okay.
Right.
So let's do the right-hand side first, because this should be easy. What is left over after we multiply these guys together?
1 second, I'm writing it out.
Okay.
All right. The right-hand side.
On the right-hand side, yeah.
You'll have T plus 1.
T plus 1 is one of them.
Times T plus 6.
Yeah.
Times T.
What is 2T divided by T?
T over 1. Wait. No, what doesn't one of the T's cancel?
One of the T's can't. Well, both of the T's cancel. The T cancels out completely.
Oh.
Yeah.
Right.
Here's another way of looking at it. Because remember how we wrote it as T plus T? We have T plus T over T. And so it's like, well, I need to factor out a T, right? And so we do that, and we have if we were to factor out 1t, you would have t times 1 plus 1 over t.
Okay.
And then those guys cancel, right? And so you're left with just 1 plus 1, or in other words, 2. That's why we did it that way. So it's not like, so remember, it's, yeah, and so when you're multiplying by, right, those constants just kind of float around. Now, if it were, you're thinking, oh, I have 2 t's in the numerator. No, you don't. 2 t's in the numerator would be t squared over t, right?
Sure.
That would mean that you have a t times a t over a t, and then one of those guys would cancel. In this case, you just have a 2 times a t over t. So if, say, I'm just really want to beat this in. I know that you get this now, and it was, but I'm just going to say, if t were, say, 5, we would have 2 times 5 divided by 5. And we'd see, well, that should be 2 because that's just 10 over 5. Or in other words, 2 times 5 over 5. And yes, the 5s cancel, and you're left with just a 2. And so that's why the t's cancel in that case. And so we are left on the outside there, how we're writing it. The t kills one of those t's, and we're left with just a 2. There we go. Okay. Now, on the right-hand side, you got to imagine that I've written this right here, the t plus 1, t plus 6, 2t. Let's just imagine that I've written it out here, but I'm running out of room. So now we're distributing that guy into each one of these. And tell me what happens when this guy jumps over and hits this first one right here. What's left over?
Okay, so you have t plus 6 times 2t.
Yes, so t plus 6 times 2t
Plus t plus 1 times t, or 2t.
t plus 1 times 2t, and then what's left on that last one?
Plus t plus 1 times t plus 6. Also, you're getting it up.
Oh no! Okay. Give me just a second.
Yeah.
All right. Not coming back up. Hey, there we go. Yay, it worked. Okay, so what we said here, we're left with t plus 6 times 2t plus 2 plus 1 times 2t plus t plus 1 times t plus 6 equals t plus 1 t plus 6 times 2. Okay. Now what do you want to do?
I suppose we should simplify.
Yeah, that's what I'm thinking we should do. So where do you want to start?
Probably just the left-hand side.
Let's do it. Okay.
Let's go.
What do we get when we multiply these guys out?
You would get 3t, I think. No. Hold on. You'd get, hold on. 2t squared.
2t squared. Good. 2t squared plus
12. 6 times 2 is 12. 12t.
12t. Good. Now what about in the second one?
2t squared plus 2t.
Plus 2t. All right. Now the hard one.
T squared
Yep.
plus 6t plus t, so just 7t.
So plus 7t. Yep.
And then plus 6.
Plus 6. Now, one thing you'll notice is that this is the exact same thing with a 2 out front, right? So let's just write that 2 out front, and then I'm just going to copy down that same thing that we just did. First outer, inner, last gives us the same thing, t squared. Outer gives me 6t, inner gives me 1t, I get 7t. Finally, plus 6, and that's all multiplied by 2, right? So all I did is I multiplied that guy out. Didn't really use my brain because, well, I have all those right there. Now, I mean, if we want to be really slick, which I say let's not, because we want to do this systematically, and we want to get in the habit of doing these the same way every time. You could notice, like, hey, I have 2 apples on this side and 1 apple on this side. I could just subtract this 1 apple from over here, and I'd be left with 1 apple on this side. But I don't want to, like, that just happens to work out that way. So let's just do this systematically and deal with this term by term. How about, let's work on the left-hand side first. And let's collect all of the t squared terms first. How many t squared terms are there?
3.
You can start by spelling.
Okay, and what do they add up to give me?
2 plus 2 is 4 plus 1 is 5.
Okay, so I have on the left-hand side 5t squared. Now, what about the t terms? What do we?
12 plus 14 and 7 is 20. 2, 21.
I think 21. Let's do it this way.
Yeah.
7 is 9. 9 plus 12 is 21. So plus 21t. Man, I'm buying new dry erase markers today, but okay.
Your video is
Okay, we're just gonna have to scrap this. Give me a second. Thank you. All right.
Oh boy.
Ugh. All right. So that looks terrible, but we have 5t squared plus 21t plus what?
6.
Plus 6. That's the only thing left over there. Okay. So plus 6. Okay, now what about the right-hand side?
You multiply everything by 2, right?
This guy's going to distribute over into each one of these.
All right, so you have 2t squared plus 14t plus 12.
Plus 12. Okay, so now I'm going to erase the top stuff and take this and rewrite it up here. All of this we have dealt with. Remembering that we're solving for t.
Okay.
So let's see. We have t squared plus 21t plus 6 equals 2t squared plus 14t plus 12. Now what do you want to do?
I think you should subtract 2t squared from both sides.
I like that. And what does that give me on the left-hand side?
3t squared.
3t squared. Now what do you want to do?
Subtract 14t from both sides.
Yep. And what's left over?
7t.
Plus 7t on that side. Yes. Okay, so those guys are gone. Now what?
Subtract 6 from both sides. And you get 6 on the other side.
Okay, now what do you want?
No, I guess you should wait. Subtract 12 from both sides so that you get -6 on that side, and then you get a 0.
No, there we go. That is what we want to do. And like I think I said this last time, pretty much anytime you have a quadratic, the only way that we know as of yet how to solve it is to take the whole thing equal to 0. And that is not going to change when we learn some more high-powered methods of solving these guys. We're almost always, when we have a polynomial, we will want to set that guy equal to 0. And so now that we've done that, what do?
Factor it.
We need to factor this guy. And so I'm going to go ahead and make this equals 0. And what goes in the front? What's the only thing that can go in the first one?
A 3t and a 1t, or just a t, I guess.
Yep, exactly. That's the only way, by using integers, to break this guy down into something times something equals 3t squared. So, okay, now here comes the hard part. We need the last two to multiply to give me a -6. So what are my possibilities?
Well, you have 6 and -1, or
-1. So we could do 6 and 1 here.
Yeah. Oh, I guess it would be -6 times 1.
Okay.
Maybe.
So the outer would be 3t. The inner would be -6t. That's not going to work.
No. You have 3 and 2.
3 and 2. So where do you want to put the 3 and where do you want to put the 2?
I guess put the 3 first and the 2 second.
Okay. Now the outer gives me 6. The inner gives me 3. There's no way to plus or minus these guys to give me 7. So we would have a minus. Yeah, that's not giving me 7 anyway, anyhow. So I like 3 and 2. Let's try 3 and 2 a different.
Okay, so you have 9. If you swap them, you have 2 and 3, and then so 3 times 3 is 9, and then 2 and 9 minus 2 is 7.
So where does the minus go?
In front of the 2, I believe.
Yes, I agree. Okay, and so then the other one has to be plus in order to give us a -6. And so now let's just check it. We're just going to check this one more time to make sure that we didn't mess this up. First gives me 3t squared. Outside gives me plus 9t. Inside gives me -2t. Finally, -6, because we have the -2 and the +3 gives me -6. That does indeed come out to 3t squared plus 7t minus 6 equals 0. Okay, so then what does t equal? What are my possibilities for t?
Either -3 or
when you're in doubt, just write it out. Because remember, that whole thing has to be 0. And now just solve that guy for t.
So add 2 to both sides and 3t, so 2/3.
T equals 2/3 would be the other one. Okay, so those are our two possibilities. That is my solution set. The set of solutions, t, which make that true, are either -3 or 2/3. So which one of those is going to be our solution?
Wait, what?
Well, they're both of them aren't true. One of them is obviously false. Because remember, what is this? What did t represent in the very beginning of the problem?
Hours, right? No, wait.
Right, the amount of time it took for 3 trucks to do a job. Did the trucks do it in negative time?
No.
Was it done 3 hours before they started? No.
No.
So there's only one possibility. That means that t equals what?
2/3.
2/3. 2/3 of an hour. We could write like that, or we could say t equals 0.66 hours or whatever. 2/3. I'd much prefer 2/3. That makes sense to me. 2/3 of an hour for the 3 trucks to do the job themselves. Or together. Together. Sorry. So that's that one. Are we good?
Yes.
Okay, cool. Any other questions from that homework or anything else for that matter?
I don't think so.
Okay, cool. So moving on.
And this felt pretty clear.
Okay, good. So the first thing I'm just going to say, we're not going to do section 8, chapter 6, section 8. It's called formulas, and it's just what we've been doing, but instead of X's and Y's, they give you a bunch of crazy variables. But it's the exact same thing. And for the interests of time, we are going to move on and not talk about it. If you could solve it with X's and Y's, you could solve the same kind of thing with R's and E's and T's. So there's nothing new there other than to get you used to dealing with equations of, say, this form, where they have T1 equals T2 and T3.
Well, that looks confusing.
Yeah, but that's the idea. And it's good to be able to work with those things. And I mean, if we had an infinite amount of time, we'd totally do this. It's just that this is no different from, say, having this equation right here. And if I told you if this said solve for T3, this would be the same thing as having this and saying solve for Z. In which case we would just multiply, we kill denominators and then get Z by himself. The only difference with this is we kill denominators and then get what we call T3 by itself. But so we're not gonna mess with that just because we want to move on.
Are we ever going to cover the quadratic formula?
Oh, we will.
Okay.
We are absolutely going to do that. That's what a lot of this is leading up to, as a matter of fact. And we're going to prove it. We are going to, in painstaking detail, prove the quadratic formula.
Oh boy.
Yeah, but it's actually, and the book even works towards it too. And then the book kind of glosses over the what we could call the main theorem of the class. The book is set, and most books are, that you do a bunch of exercises and stuff and learn a bunch of new methods in order to get to solving the quadratic formula, or solving a general quadratic equation. And and so by the time we get to it, we will have worked, we will have all of the tools in play to do that. There's just one more thing we have to do, and that's chapter 7, where we're dealing with radicals, right? Stuff like this.
Oh boy.
Right, like that kind of guy. And so once we do that, then we'll have, then we need to learn one method called completing the square, which is the hardest thing in this class. Easily, it's the hardest thing.
I remember doing that from Algebra 1, and it was terrible.
It is terrible. Luckily, just like with matrices, I have a method. I have a method that was taught to me by the most hard-ass math teacher I've ever had, and I thank him to this day that it was taught this way, because yes, it's difficult, just like matrices, right? You put in a little bit of work, right? It takes some extra effort to get there, but then once you've done that work, the payoff is huge, you know? And so that's what we're gonna do. We are definitely going there. That is, in fact, the point of everything we've been doing up until this point, is to get that quadratic formula. So today we are skipping section 8 and moving right on to section 9. I was going to just skip this, but we really shouldn't, because you will see this in your future. I guarantee it. And so it's good to talk about. So section 9 is talking about variation. And there are two things we need to know. We're going to say there's direct variation. And direct variation is, well, I'm just going to read it right out of your book. It says, whenever a situation translates to a linear function, f of x equals kx, where k is some constant. We're using k here, or they also have, or y equals kx. This is no different. Since k is going to be a constant in this case, we could think about this as mx, right? Like y equals mx. In other words, when you have a line, that is all we're talking about. But we are going to be using the constant. For our constants today, we're going to either give it the name k or the name c. But when you see that for the rest of the day, remember, this is just some number, right? K might be the number 7, or k might be the number 3/8 or something like that. K is just some constant number. It does not vary. That's why we call it a constant. It is not a variable. It doesn't move. It doesn't change. The only things that change are the x and the y values. Okay, so direct variation is when you have a situation like this that translates to a linear function where k is a non-zero constant. K is not equal to 0. K is constant. Okay. We say there is direct variation. And this is said in two ways. We say that there is direct variation or, and this is, so you might hear this as, there is direct variation in this relationship, and blah, 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 blah. More often, you will hear it this way. We say y varies directly with x. Okay. That is what you're going to see more often than anything else. Y varies directly with x. And all that means, so when you see this, that means that there is a constant k such that y equals kx. Now, how does this come out in, I guess I'll just use this example. Why not? So in the constant of variation, where? So, and what we're going to do is you will be given some kind of situation that I'm about to give you right now. And what we are going to want to do is write this, find what this is, and then they might ask you to predict something else. For instance, so now remember, like from day one, I said math is this is the kind of thing they do. They give you something really high level and it sounds abstract and you're like, how am I ever going to apply that to anything? That's just the way it is. Get used to it, right? That's what I'm doing right now. I'm giving you high level stuff. It's good to know all of this and have it written down, but as we start to do some examples, it will become clear. So in other words, the big takeaway is if you ever hear something like height varies directly with weight, then what that means is there is a constant k such that height equals that constant times weight. Or whatever that happens to be, okay? So, okay. For instance, if I say y varies directly with x, so suppose, hey bud, y varies directly with, I'm going to use this abbreviation to save time. Suppose that y varies directly with x and that y equals 32 when x equals 2. Okay, so let's break this apart. Suppose that there's two clauses here, right? Suppose y varies directly with x and that y equals 32 when x equals 2. Well, all this says is that y varies directly with x. Therefore, there is a constant k such that y equals kx. That's all that means. Now, they're also giving us a little bit more information. They're saying that when x is equal to 2, then y is equal to 32. So this should be very familiar. In fact, it's almost exactly like a line, right? When we know that something lies on a line, and then they give us some more information about that line, we plug in a value in order to find, say, the slope or the intercept or something like that. It's precisely what we're doing here. It's just that our line happens to be even easier because the intercept is always going to be 0 whenever you're talking about direct variation. So now all we need to do is plug these values in and say, well, okay, when my input is 2, so in other words, when x is equal to 2, my output, the y value, is 32. Now, can we solve for k?
Mm-hmm.
We can. How do we do that?
Divide both sides by 2.
Divide both sides by 2. And that tells me that k equals what?
16.
16. So now I have my formula. I could say, okay, in your homework, pay attention. In your homework for every one of these, even if it just says find some value, I want the formula. I want the function for every single one of these. You're going to write it down anyway. Just put a box around it or something, right? Like when you get to this point and you found this, then say, oh, okay, then y equals 16x. That is my function, which defines this situation right here. Y varies directly with x, and it happens to be the case that when x is equal to 2, y is equal to 32. Cool. Then in your homework and stuff like that, and for the rest of your life, every time you see one of these guys, sorry, I just got something popped up, go away, okay. Then they're going to give you some situation like this, and then they'll say, predict what y is when x equals 4. And so then we just take this and say, well, okay, when x is equal to 4, then y is equal to 16 times 4, which is, I don't know, it's like 64 or something. I think it's 64. Yeah, it's 64. Y is equal to 64. All right. And then that's pretty much what your half of your homework is going to be. I'll say y varies directly with x, or height varies directly with weight. And when something, predict the height when the weight is 4. And then you do this type of thing, and that's that. You following so far?
Yes.
Okay, so now what we've got to be careful with is it's easy for us to get into our minds that k is like some whole number, or that k has to be an integer or something like that. That may or may not happen. So for instance, one of the problems, Oh, that was that one. We'll do that one in a second. But from your homework, number 8. Number 8 says, so it's just a bunch of them. And it says, find the constant of variation and equation of variation. That's what I'm looking for, the equation or the function that we just wrote down, where y varies directly as x. Y varies directly as. Sometimes they say with, sometimes they say as. Just sorry, suck it up. They do that. So y varies directly as x, and then there's a bunch of different ones. For number 8, it says y equals 0.6 and x equals 0.4. Okay, so what y varies directly as x. Okay, so what does this mean? Y varies directly as x means
that they vary directly.
say what? Well, yeah, it means that they vary directly, which means what? It means that there should be some formula that we
can, y equals kx.
Y equals kx, right? So just, and if you take nothing away from this section, just this is, as long as you remember this, you're good to go. Like this will show up in chemistry, it'll show up in physics, it'll show up in math, it's going to show up everywhere. And when you see this, y varies directly as x means exactly this. This is what that means. That is a fancy way of saying this right here, that there's some constant x or some constant k that makes this true. Okay. It also tells us this right here. So how do we find k? What do we do?
You have your 0.6 equals k times 0.4.
0.6 equals k times 0.4.
And now you divide both sides by 0.4, okay. And you should get 1.5 for k.
1.5 for k. 6 over 4 is 1 2/4. Yes, I agree. 1 2/4 is 1.5. Good. Okay, good.
And so if the math book is using decimals, do you want me to use decimals and not like fractions or whatever?
Yeah, okay. Or whatever you're more comfortable with, but yeah, usually that's a good rule of thumb, especially in, say, chemistry and physics, or if you're doing any kind of scientific anything. If information you're given is in decimals, give your answer as decimals. So we're going to just kind of use that as a rule of thumb always and forever. So it says define the equation of variation. It actually says define the constant and the equation. There's the constant. The equation is what happens when I simply plug that constant back in. And there you go. That's all we got to do. Okay. Let's do one actual example of these right here. Number 16. So that's, I'm only going to assign one from this group, like 1 through 8, and one from the group 9 through 14, because it's just this over and over and over again. Then we get into word problems. Yay, word problems. So this is number 16. It says, Hooke's law states that the distance d, the distance of a spring is stretched. Hooke's law states that the distance
that's what I saw.
That a spring, I'm drawing a spring here, the distance d, that it is stretched by a hanging object. So we have some weight. You're imagining a spring being stretched by an object that has weight w. So the distance stretched by a weight by the weight of a hanging object varies directly. I'm sorry. The distance stretched by a hanging object varies directly as the weight of an object. Weight of the object. Okay. Translate this for me. What does that mean in math speak? D and
so
W.
D equals I guess KW.
There you go. That's all that means. All of that I messed up 3 times as I was saying it. All of that just means that there's some constant K, and D equals K times W. That simple. Okay, now it says the distance is 40 centimeters. The distance is 40 centimeters when the weight is 3 kilograms. It says predict the distance when weight is 5 kilograms. Okay, so they've given us an ordered pair, right? We have one unknown, kind of thinking about this as a line here, like if this were y equals mx instead of d equals kw, and we wanted to find, what's the slope? Well, if you gave me a point right here for this guy, if we know that when I plug in one of these, I get out another one of these, then I could just solve for m. That's what we're doing with k right now, right? So how do I solve for k? What am I doing?
So you have 40 equals K times 3.
40 equals k times 3, which means that k equals what?
Well, you divide both sides by 3 and then you get 40 over 3.
There we go. Let's not make it too hard. Let's just call it that. We could, and in this case, I mean, if you want to use decimals for this, that's all right.
You can't really use decimals, I don't think, because it just repeats.
Exactly. And that's exactly, you beat me to the punch. I was going to say you could, but if you're going to chop it off and with over 3, it's 3 repeating. And so your answer is going to suck. It'll be much better to just wait until the end, right? So in this case, yes, I want to use that. Another thing, they didn't give me any decimals in the problem, right? There are no decimals in this problem, so I don't want to use decimals unless I have to. So we found that D equals 40 over 3 times W. So now they're saying predict the distance when weight is 5 kilograms. What do I do?
So then you do, you have your formula, and then you do D equals 40 over 3 times 5. So you substitute 5 for W, and then you get 66 something.
Whatever. 5 times 40 is a 0 and a 20, so 200 over 3. The distance is 200 over 3 what's?
Centimeters?
Centimeters. There we go. That would be your answer. So in your homework, what I'm going to be looking for is that you've boxed 2 things for each one of these. One of them is we're going to call it your function, right? Because that's a function. It's an input-output relationship right there. And we boxed it, so I know that's your model, right? We're modeling the behavior of the real world. That's how you do it. And then the answer to the specific problem is predict the distance when the weight is this. You do your work, you plug it in, that's your output. That is your answer right there. That's what'll be in the back of the book when you go to check your answers. This, though, I do want to see. That's what really the main point of all of this stuff right here. Okay, so moving on. You ready to move on? Any questions thus far?
No questions.
It's really straightforward stuff. And I almost said we should just skip it, and I was just going to mention, something, but it's important that you've seen this and actually worked with it before.
I'm very glad that we went over this because I remember doing this in Algebra 1, and the way my teacher talked about it and described it made absolutely no sense to me. And for some reason, like the easiest thing made absolutely no sense to me for the entirety of the class.
Interesting. That's the way it goes. And again, one of the reasons why, because I remember I didn't see this until I took chemistry. Somehow I skated by without seeing it in math. Took chemistry, and it was like a major problem for me until at some point I realized, oh, this means this right here. All this fancy way of saying that there is some constant K that's non-zero that makes this true right here. And so, okay, moving on. So that is direct variation. There's another type of variation, and it's called inverse variation. And I want to see if I could do this. I was really, let's do that. And it's non-zero constant, inverse varies inversely with the constant. So there's, watch what I'm going to do. Everywhere that I see direct, I'm going to change direct. These are going to look a little different. Okay, so there's another kind of variation called inverse variation. And what that means is that there is some constant K that's non-zero, such that your function is K over X, or Y equals K over X. So there's really two situations here. Either Y is going to equal some constant times X, or Y is going to equal some constant divided by X. Those are the only two possibilities. When it's inverse variation, and you can kind of see like, inverse here, this is the, if you think about multiplication, what's the inverse of multiplication? Division. And so that's why it's called inverse variation. So when you have a situation in the real world where this happens or this happens, we say there is inverse variation. But most often we will say Y varies inversely with X. So whenever you see, and I'm going to go through this again, whenever you see this right here, this phrase, Y varies inversely with X, that means there is a constant K such that Y equals K over X. 99% of these problems involve translating this statement into this statement right here. Translating it from our common speak into math speak. So, okay. Let's do a couple examples, just like we did before. Let's do an easy one. And I want to make sure that that's not easy. That one's easy. Let's do that one. So we'll say, so this is number 10. Like I said before, these are, for each one of these, it says, find the constant of variation and the equation of variation, given that Y varies inversely as X, and Y equals, I want to do that one, 16, when X equals 4. Okay, so Y varies inversely as X. What does that mean?
Y equals K over X.
Yeah, it means that there is some constant that does not change, a constant K, such that this is true. It's also true that whenever X is equal to 4, Y is equal to 16. So what do I do to find K?
You multiply each side by 4.
Well, yeah, but first, let's go ahead.
Oh, sorry. I was already.
I know, you're
Sorry.
better.
You have 16 equals K over 4.
There we go. And now
Now you multiply both sides
now
by
you
4.
multiply 4, and I get 16 times 4 equals K. 16 times 4, I think we just did this one. It should be
64.
64. Okay, equals K. So therefore, okay, that was one thing they were looking for. They were also looking for, and I'm looking for in every single one of these, that you write the equation, which is in this case 64 over X, just like that. And you put a nice box around it so I can see it and go, yes, that's it. Then if they were to ask some question like predict what Y is when X equals 32, you would say, well, I just plug 32 in, 64 divided by 32, I believe is 2. So there you go. So that's those. The other kind that you're going to see, oh, sorry, I just erased all of this. My
That's
bad.
okay.
All right, good. The other kind, which one did I want to do? It's directly. Okay. We're going to do number 24. I'll try to do a better job of stating this. The time required to drive a fixed distance. The time, t, and they even give you the variable, like, you can't ask for anything better than that. So the time t required to drive a fixed distance, required to drive, I'm not going to write a fixed distance, varies inversely as the speed. Varies inversely as the speed. Here for speed, it's not an S like you think it would be, because S and T are like right next to each other. X and Y are right next to each other. No, they're saying R because it's a rate, but whatever. Okay. Varies inversely as the speed. Okay. It takes 5 hours. It takes 5 hours at 80 kilometers per hour to drive a fixed distance. I didn't write that in there, but to drive a fixed distance, to drive a fixed distance. How long would it take to drive that fixed distance? At fixed distance at 60 kilometers per hour.
Oh boy.
Okay, now break this down into bits. The time t required to drive a fixed distance varies inversely as the speed. Can we go ahead and just translate that into math speak?
Yes. So you have T equals K over R.
There you go. K over R. All right. Now, okay. So now it says it takes 5 hours at that long to drive a fixed distance. How long would it take to drive that same fixed distance? They don't say that same fixed distance. In here it says to drive a fixed distance. you have to assume that they're talking about the same fixed distance. So that's why I'm saying, how long would it take to drive that very same fixed distance at 60 kilometers per hour? So what information are we going to use to find the constant? Because that is always like step number one. We have some relationship. The only thing we don't know about this relationship is K. And so to find K, what am I going to plug in?
You'll have 5 equals K over 80, I think.
There we go. 5 equals K over 80. Now let me just double check that. We said T was time required to drive. And it says it takes 5 hours as the time required to drive. Okay. Now it says that the speed is R. So that's the speed right there. They've given me 80 kilometers per hour. So yeah, that's the speed that we're driving. So that's where that goes. Okay, nice. What's K?
400.
400, because 80 times 5 is 400 equals K. So now, I'm going to go ahead and plug that guy back in to satisfy Justin's special requirements for this homework. I have this written down and I've put a box around it. That way Justin knows, okay, you got it. Good, excellent. Now, how long would it take to drive that fixed distance at 60 kilometers per hour? What do I do?
You know what happened?
Well, you solve for T, so you have T equals 400 over 60.
There we go. T equals over 60, which is 40 over 6, which we're done. That's fine. That I don't care. That's good. But what is it? It's not 40 over 6 jelly beans. It's 40 over 6 what's?
Hours.
Hours. I would like to see units at the end. That would be the answer right there. 40 over 6 hours. One more thing I want to say on this homework. It is really, really straightforward. They're all just like this. In every case, you're going to say, wait a minute, is it inverse variation or direct variation? If it's direct, I'm going to write y equals mx. If it's inverse, I'm going to write y equals k over x. And then finding the place that will give you k. So you set up your equation, solve for k, plug k in a minute, buddy. Plug k back into your equation, put a box around it. Then do whatever kind of special stuff they're asking you to do. They might have asked, instead of this, how long would it take to drive a fixed distance? They could have said, if it took 1 hour to drive that fixed distance, what speed would you have to go? In which case you'd say, well, instead of giving me R like they did in this case, they gave me T and they're asking me to solve for R. So I would just plug in 1 right here and solve. Does that make sense?
Mm-hmm.
It's that I haven't looked through all of these, but I wouldn't be surprised if they try to throw you through a loop like that. Like in every case, they up until a certain point, you've been setting it up like this, and you're always solving for the dependent variable here, like the output variable. They very well might say, just flip it up on you and say, well, then what's this here? And blah, blah, blah. So, okay. The only real tricky thing besides that right there is going to be a situation like this. It is number 13. Oh, no, I don't want to do 13 because that's one you're going to do. Number 14 right here. This is the same, in that same group of problems where they tell you y varies inversely as x. And y equals 81. Then, and here's the trick, x equals 1 over 9. Okay, so first part of this, What does that mean? Y varies inversely as X.
Y equals K over X.
Y equals K over X. It means there is some constant value at K so that when I do this, yeah, okay. So what do I do to find K?
So you have 81 equals K over 1 over 9. So
Over 1 over 9. And that's the tricky thing, right? Now we have a fraction in the denominator. No big deal, really. There's a couple different ways we could take care of this. But when I think of divide by a fraction, that means what?
multiply by its reciprocal.
Right, so I have K in the top and I multiply by
9 over 1.
9 over 1, which I'm not even going to write.
It's just 9.
1 is just 9. And so now I have 81 equals K times 9. And then I do what?
Divide by 9.
K equals what?
9.
9, yeah. And so my equation of variation is what?
Y equals 9 over X.
Yes. Yes. So it can be a little tricky when they throw those into the mix. So, okay, almost done here. We're actually, wow, we're doing great on time. Well, for me, we're doing great on time for me. Now, okay, are you good here?
Yes.
With all this, okay. One thing I want to say. Suppose that A, I don't want to use A because I think that's actually in your book. I want to do it this way. Let's just use Z and W. Let's say that Z varies directly with W. What does that mean?
Z equals KW.
There you go. It means that there is some constant K such that that works. Okay. Now, watch this. Now remember K is non-zero, right? And kind of has to be, otherwise you've told me nothing, right? Like it's part of it's assumed in there that your constant is not zero. Otherwise, there's no relationship there. If it is zero, you just have Z. It's a big deal, right? So there's no variation. Z can't vary because Z is always zero. So it's understood that that's not zero. Well, if it's not zero, I could divide by it, right?
I think so.
Why not? Right? I mean, like, the only thing I can't divide by is zero. So if K is some constant, I never have a problem dividing by it. So now I have Z over K, and I don't like the way that looks. In fact, that's the same thing as 1 over K times Z, right? Okay, buddy, I'm sorry. Give me just a second. Give me just a second. So for instance, if we did some figuring out, oh, I love you, buddy. Okay. So we've done we've done some solving. We have some, they say Z varies directly with W. And when you plug in this, you get out this. And let's say we found that K was equal to 2. Then it is the case that Z equals 2W. And then I could just say, well, divide both sides by 2, you get Z over 2 equals W. Or equivalently, I could say then 1/2 times Z equals W. So that's all I've done here, right? I'm just trying to keep it a bit more general that we end up with something like this. Now, we've also seen that K can be a rational number. It could be a decimal, right? Like we had earlier, K was a decimal. Same kind of situation here. This is a decimal. That's perfectly fine. It's a constant, right? So what I'm getting at here is, check this out. This is just a constant. 1/2 is a constant. 1/k, since k is a constant, is itself a constant. So let's just write it as c for that constant. So in other words, 1/k is equal to c is constant. Because k is constant. K is not changing. Okay. So this by definition means what? There's a constant. Maybe if I did it like this.
Oh, so it varies directly?
It means there is a constant such that I multiply that constant by that thing and I get that thing. So that means that W varies directly with Z. So in other words, if Z varies directly with W, then there's an equation Z equals some constant times W. But if that's true, it's also true that there is another constant so that W equals that constant times Z, which by definition means that W varies directly with Z. And so this is just something to know, that if X varies directly with Y, then Y varies directly with X as well. And we just have to be careful about, and so even if you mess them up, what I'm getting at here is even if you write them the wrong way, right? You're still good as long as you keep everything in well. It's good to know that that this is a symmetric relationship, that Z varies directly with W, therefore W varies directly with Z.
Right.
Guess what with inverse variation? If Y varies inversely with X, guess what X does with Y?
X will vary inversely with Y.
In your homework, you are going to use that fact. Basically, it says, is it sometimes, always, or never true that this type of thing? And I want you to go a little bit beyond saying like yes or no. I would like to see some kind of proof. This, as far as I'm concerned, is a proof, right? This is almost exactly what you want to write for that. I would like a little bit more though. I would say, like in this case, I would say since C is constant, then there is a constant C such that this is true. So then by definition, this, because remember this, the way we have defined it, something varies directly with something means there is a constant such that this is true. And so you're going to do pretty much exactly this with one of the problems. With the other problem, it's going to be inverse variation, but it's pretty much the exact same thing. And so, yeah, any questions on this?
No questions.
Okay, cool. All right, so time for homework. Okay, I'm getting rid of all this. Am I good to get rid of it?
Yes, sir.
All right. So we have homework. Chapter 6, section 8, I believe. Nope, 9. 9, they're not doing 8. Oh, that's mean. Oh, that's mean. Yeah. Yeah, we'll do it. Okay. It's not bad. It's just, it's a little tricky. Number 7, number 13, then 15 through, we did want to do that one. Yeah, let's do that. 15 through 29, odd. 15 through 29, odd. 31 and 32. These last two, as expected, are the challenge problems, and they're exactly what I just talked about. That, remember, it asks, sometimes, always, or never true. I just want a proof. You give me your answer and write a proof, just like I did. It doesn't have to be super formal, just like explain your reasoning. And I think that's it.